Before today, we could only observe asteroids moving in space, assess their direction and speed, and if an asteroid was rapidly approaching Earth, we could only predict when, where, and on what day it would collide with us. We had no authority over anything beyond that. But now, for the first time in human history, a mechanism to protect Earth from asteroids has been practically developed, and NASA has even demonstrated a live experiment of this mechanism to the entire world. Nassim, 630 million years ago, an asteroid the size of Mount Everest collided with our planet. This asteroid, 10 kilometers wide, changed the entire landscape of Earth. The destruction was so severe that it wiped out the dinosaurs across the planet. But today, humans have the technology to predict the trajectory of asteroids heading toward Earth. This technology is becoming more advanced over time, and we can now detect even distant asteroids. NASA currently has a list of 26,115 asteroids that will pass near Earth in the future. Among these, 16,420 are smaller than 100 meters in size. 8,007 are up to 1 kilometer in size, and 888 are large. While none of these asteroids are directly heading toward Earth right now, it is possible that over time, one of these asteroids might change its course and collide with Earth. Just a 1 kilometer wide asteroid, if it collides with Earth, would generate as much energy as 1,000 nuclear bombs. The resulting devastation might now be easier for you to imagine. While it may be possible to manage other types of disasters on our planet, avoiding an asteroid impact was considered impossible. However, NASA has now demonstrated an experiment showing that we can counter asteroids. Yes, this is a kind of planetary defense system known as the kinetic impactor technique. With this technique, we can change the path of an asteroid heading toward Earth. But the question is, how? In outer space, beyond Earth, due to the lack of gravity and atmospheric pressure, objects face no resistance. Whatever position an object is in, it stays in that position. If an object is traveling in space at a speed of n kilometers per hour, it will continue at that speed unless something intervenes. This is possible because, in space's vacuum, friction doesn't occur. Asteroids, formed millions of years ago due to collisions, have been traveling at high speeds ever since. If they come close to Earth, Earth's gravity will attract them, and their path will change. If they get too close, the asteroid could collide with our planet. To prevent this, NASA scientists proposed the idea of using a space probe to strike an asteroid at a specific angle before it enters Earth's atmosphere. The probe's collision would divert the asteroid off Earth's path. According to the plan, multiple space probes would be in orbit around Earth. When NASA detects an asteroid heading toward Earth, these probes would be directed to hit the asteroid at a precise angle. To test this theory and see if it's possible, NASA decided to conduct an experiment. They named this mission DART, which stands for Double Asteroid Redirection Test. On November 23, 2021, NASA launched the DART spacecraft, costing $325 million, BioSpacek's Falcon rocket from Vandenberg Space for Space. Like other space probes, DART had thrusters, a camera system, and a radio link to transmit live image feeds to NASA. A few hours later, it entered Earth's orbit. NASA then needed a suitable asteroid for the collision. 1 crore kilometers away, there was an asteroid 170 meters wide, named Dimorphos, orbiting a larger planet. Although small compared to our moon, it weighed around 500 billion kilograms. Its height, mass, and distance from Earth made it a perfect target for DART. DART itself weighed just 579 kilograms, which was only 0.0001% of Dimorphos's mass. But in space physics, speed matters more than weight. NASA scientists calculated that if DART struck Dimorphos at 23,000 kilometers per hour, the asteroid's direction could change by 1%. After extensive calculations, DART was redirected to the asteroid Dimorphos, 1 crore kilometers away. After months of travel, on September 26, 2022, with just hours remaining before the collision, NASA shared live footage from DART's camera. In the footage, we can see DART speeding at 23,000 kilometers per hour, crossing the smaller planet, and finally colliding with Dimorphos, which was about the size of 2 football fields. This was the last image received from DART, after which the connection was permanently lost. This collision marked a moment of immense joy for NASA scientists. For the first time in history, a planetary defense system had been tested. Experts believed that after the collision, DART would have shattered, while Dimorphos would have shifted to a new orbit. The exact result of the mission will be available in a few weeks, revealing whether the spacecraft's speed was enough to alter the direction of an asteroid 1 crore times heavier than itself. While this was just an experiment on a small asteroid, the real question is whether the same formula will work on a 10-kilometer wide asteroid. Have we forgotten that the largest impact crater on Earth, the Red Fort, stretches 300 kilometers? Could an asteroid the size of 300 kilometers create a similar crater? Can we combat that? What do you think about this? Please share your thoughts in the comments section. I hope you like and share this video from Discover TV. Thank you so much for your love and comments. See you in the next amazing video.